Okay, as the email said, problem set number 3, as in this spreadsheet, is on the Moodle site, but I thought it might still be useful to have a quasi-live demonstration on what was going on, how to do things. So this is that. I found a fancy little function in Windows here that seems to be pretty good recordings, but I may have to make a bunch of them so they're not too large. We'll see how it goes. White horse weather, question number 1. First step here is actually to make 2 new variables. So this was given in the hint document. Ultimately, we want this 2 by 2 table with temperature over here and snowfall up here. We don't have those variables directly, so we need to use an equation, a function, that would look at the temperatures and say whether or not it is less than -10 or greater than -10. Presumably somewhere in there you have a less than or equal to or greater than or equal to. I didn't care which way you did it. Same thing here with snowfall. We have snow on ground, but we have to convert that to, well, did it snow or not? Snow on ground is not the same thing as snow falling on the ground. So as the guidance document mentioned, we look at the change in snow on ground to do that. So if on this particular day there is 19 centimeters, and if there's still 19 centimeters the next day, we're going to assume that no, it did not snow. And if it jumped from 19 to 26, then yes, some snow did fall, and so we get snowfall. If we go from 26 to 19, so a decrease in the snow on ground, then we will also assume that there's no snowfall. The question made a caveat that snow didn't fall and melt on the same day, so we don't have to worry about that. So now you have your 2 variables. We can throw this directly into a pivot table. So again, we'll get temperature here and snowfall up here. And we want the count of the data. Note that we don't want well, there's no number, so you don't have to worry about a sum. We want count the number of rows that have snowfall and the number of rows that have no snowfall as a variable, those guys. And the pivot table will give us a count for all of these. So over here I have the actual questions. Question part 1a was asking for the proportion of data with no snow. So a proportion, it's a ratio, it's a fraction. The numerator, the top part, is the count of things we care about, and the denominator, the bottom part, is the total count. So for us, if we're interested here in the proportion, the ratio, with no snow, we can look at our data. So this table is the same as this one. It's just a little easier to select things. We can look at our data and see what we want the proportion of no snow. So here's our no snowfall. There's a total of 324 days with no snowfall. That's the count of things we care about. And we want to divide that by the total count, which I have highlighted because we'll use it a lot here, which is 365 days. So 324 divided by 365. You could leave it as a fraction or you can convert it to a decimal. Either way. And that's all there is to it for question 1a. For question number 2, we want the probability of no snow. Well, this is an empirical probability. We're just talking about data. There's no normal curves or anything like that. In fact, this comes... no, we had introduced normal curves, but this is still just an empirical probability. It comes straight out of the data. No theory necessary. And so our empirical probability is also a proportion. They mean the exact same thing. So our probability of no snow is the amount of days, the amount of data that had no snow divided by the total number of days. And we should get, and do get, the exact same number. So the proportion and the probability, at least when we're talking an empirical probability, means the exact same thing. That is not the case with part 3 here, or part C, I guess, where we have the probability of less than -10 and it snowing. So the and here is critical. You might be tempted to use the rules of probability, because we did have a whole lecture on the and rule and the or rule and those sorts of things. If you have data, please resist the temptation to use the rules of probability. And here's why. Let's use the actual data and calculate this probability. So the correct answer for part C here, with the probability of less than -10. So here's our less than -10 column. So that's 73. out of 365, and snowfall. So there's our snowfall column, 41 out of 365. So we want both of these to happen. So we want the -10 and the snowfall. That's this particular cell. So 18 times out of 365 potential opportunities, it was less than -10 and it snowed. So our probability of less than 10 and snow, the kind of intersection of this table, is 18 divided by 365, or about 5%. Now, if we tried to do this using the rules of probability, then we would have to make the assumption, or we might be tempted to make the assumption, that these are independent. So less than -10 degrees is independent from snowfall. And in that case, the probability would be the count of less than 10 degrees, which is 73, divided by the total, 365. The AND rule says we multiply, so let's multiply by the probability of snowfall, which is 41 divided by 365, and we get 2%. So the AND rule, assuming independence, which is what we kind of have to do here in the table, tells us it's 2%. But the real answer, using the data in the table, the actual cell here, really kind of the easier way of doing it, tells us the probability is actually 5%. So that difference tells us that temperature, this -10 degrees, is not independent from snowfall. In fact, if you think back to the probability lecture, you might remember that, well, the AND rule is actually a little more specific than one number, the probability of A times the probability of B. It's actually the probability, in fact, we can spell this out, the probability of A times the probability of B given that A happened. That's actually the AND rule, and this is why the AND rule is what it is. So we just did the probability of A times the probability of B. That is this, probability of A times probability of B. Let's go put it over here in front. And that was 2%. The real answer is 5%. And the difference is that B given A. So if we just scoot that over here, B given A is actually later on in the problem. That's why I have the problem kind of arranged this way. Perhaps I should have switched them around. But so let's put this on hold until we get to this last one, then we'll see why the probability is 5%. For part D, we have the probability of it being greater than -10 or no snow. So this is the OR rule, and it's the OR rule given the table. So we have the probability of greater than -10, so that's this row here. Let's actually put that in a specific color, so I want orange. So that's the probability of greater than 10, 292 over 365, or no snow. So here's our no snowfall, put that in orange too. So that's 324 over 365. Now we can see here in the table there's one cell, this guy right here, that is, it appears in both of those. So the 269, well, that's really hard to see. Let's make that light blue. So that 269 was part of our count for the temperature. It's also part of our count for no snowfall. So those 269 days out of 365 are getting double counted. We have to account for that by subtracting it. And if you were to look back in the slides on the OR rule of probability, you'll see it is the probability of A, this 292 over 365, plus the probability of B, 324 over 365, and then you have to subtract out the A and B, the place where it overlaps, and that's all spelled out here. That gives you about 95%, which kind of makes sense, saying most of the days in the year it is not snowing and not particularly cold. Which brings us back to this last one. If you remember from like 3 minutes ago, this was the and rule of probability, and really that probability of B given A. So this is the probability that snows given that it is less than minus 10 degrees. Let's go get rid of our highlighting here because we don't need that. So the probability of it snowing given that it's minus 10 degrees. Well, here's the minus 10 degrees. We need to start here because this is the given part. So we're starting off with one of these two cells. So that's the minus 10, and we want to know the probability that it snowed given here. Well, here's our intersection of it snowed and it's minus 10 degrees. So 18 is the thing we care about. But instead of dividing by this 365, we're only considering the number of days where it was less than 10 degrees. The snow given that it's less than 10. So it has to be in this row somewhere. So 18 divided by 73 instead. And that gives us 25%. So that's how we solve that particular case. And if we go back to our rules of probability, this probability of A given, or times probability of B given A, this is our probability of B given A. So if our probability of A, remember we're referring to this question up here, if our probability of A was less than minus 10 degrees, then there is our minus 10 degrees. 73 divided by 365 is our empirical probability for that. So 73 divided by 365. The AND rule says we multiply, which we do, but instead of multiplying by B, the snowfall, we need to multiply by the B given A, which we just said is over here. So let's just multiply it by that guy. And now we see, oh, if we account for the fact that they are not independent, so this is B given A, then we see that the probability is not 2%, it is actually 5%, which matches what we did just taking the numbers straight out of the table. Long story short, with all of this, if your data are in a table, don't worry about the rules of probability. They do still apply, especially when it comes to the AND rule. It's a lot easier just to take the numbers straight out of the table, take the thing we want divided by a total, or the thing we want divided by the subset that we want to consider, and again try and minimize our use and our concern with the rules of probability. Okay, that's question 1.